Okay, now let's apply our knowledge of how heat transfers and how things ignite to the propagation of a grass fire. So this is a grass fire, this is just a fire in grassland. Now, how do you get grass fires? Grass fires happen when you have grass that's long and has dried out. It typically happens when you have a wet winter, which means you get lots of grass growing, but then a dry summer. It takes a certain amount of time for the grass to stop being green, become yellow and dry out. But if it's hot weather, that can actually happen in just a few days. And this is known as curing, and this is a major problem in Australia, at least, and many other parts of the world. In fact, the year I'm filming this, in 2023, it's felt that this might be a major problem because we've had a very wet winter, and now there's a forecast dry summer. And grass dries out much faster than forests do, so these will often be the first fires you get after the rain stops. And the basic idea is that the fire spreads by radiation. So let's imagine you've started the fire over here, you've got the fire which is moving upwards through convection. But if you imagine you're sitting on a bit of grass sitting just by the side of a fire, the hot air is not reaching you, the hot air is being carried upwards, but from here a lot of your solid angle is going to be covered by flames. So the radiation here is going to be enough to ignite it. Whereas if you're further away, the solid angle subtended is less, so you're going to get not so much heat and therefore probably not ignite stuff. So this is the basic idea, that you've got your fire going upwards, the radiation from that comes out and hits the areas nearby, where it subtends a large solid angle and sets them alight, and so the fire spreads out. So you get a ring or a line of fire. And in fact that's what you can see here. You can see this is a ring of fire. There's the burnt area in the middle, still embers, and then a ring around the outside. But there is a problem with this. The radiation certainly will do this. It'll hit the most radiation for areas just outside the burning area because the solid angle is large. But you're actually being fought by convection. In this case, convection is trying to stop the fire spreading. So remember we saw this simulation before of the convection around a hot region in the middle of a cold region. And you can see that the air is being sucked in at the sides and then blown upwards. And so what that means is that the grass just around the outside of the burning area, yes, it's being dosed with a lot of radiation, but it's also got a lot of cold air flowing in with it, which actually helps stop it from burning. So this is a bit strange. How do fires then actually spread in this situation? Well, it turns out it has a lot to do with the exact fluid dynamics of actually a convection instability. So if you look at a fire moving across grassland, this is a deliberately set fire as part of a laboratory experiment in the United States, you can see it's not a uniform wall of fire, it's got pillars or columns of fire with relatively quiet spaces in between. And what's happening is you're not getting a uniform convection coming in and going up, you're getting columns with a lot of convection and regions in between it where the air is actually not going up but going down. And it's this actually that allows the fire to propagate. Here is a computational fluid dynamics simulation of something like this. What we've got here is we're simulating the fluid flow in a particular transparent sheet of air over the top of this white line. The ground shows the grey at the bottom shows the ground, and we've got a fire front that's coming towards us. So you can see where the fire front is here, it's moving closer and closer. And you can see that even before the fire front reaches the line where we're analysing things, you're seeing it's really stirring up the flow of air around it in a very chaotic way. Then as the fire front gets closer and closer, you start seeing a very complicated pattern with updrafts and downdrafts. See the air sometimes going up and sometimes going down. You're getting pillars and then descending air currents. It gets stronger and stronger as the fire front gets closer and closer. And again, you're getting a mix of up and down drafts. It's not all upward. It's a chaotic system due to the Rayleigh instability, it's called, of the fluid flow. Then eventually the fire front moves through. And blue colour on the ground indicates area where there's cooling due to air flowing in, and red indicates heating, where the air is actually flowing out. So it turns out that because of this chaotic nature of the airflow, it's not as simple as cold air coming in which opposes the radiation. Radiation still gives you most of the heat, but in some places you get hot drafts coming down as well, which reinforce it, and that's actually what allows these grass fires to spread.